NASA's Kepler Space Telescope has spent the last 8 years searching for Earth-like exoplanets that orbit other stars. Although the telescope's camera can't take clear pictures of bright stars, astronomers have figured out how to study stars using Kepler's distorted photographs. An international team of astronomers used the Kepler Space Telescope to look at the Pleiades, a bright star cluster that is relatively close to Earth at a little over 400 light-years away. The most brilliant stars of the Pleiades, known as the Seven Sisters, are bright enough to see with the naked eye, yet too bright for high-precision telescopes like Kepler to resolve with their cameras. Kepler was designed to look at thousands of faint stars and watch for dips in brightness that point to the presence of orbiting objects. When the telescope's camera tries to look at extremely bright stars, the images turn out distorted and overly saturated, with long spikes and other digital artifacts obstructing the view. But with some careful calculations, astronomers have used these distorted images to conduct the most detailed study to date on the variability, or changing brightness, of the Seven Sisters, the Royal Astronomical Society reports. The brightest stars in the sky, a starry countdown, the Pleiades star cluster as seen by the second Palomar Observatory Sky Survey. Credit T. White and Isizora Caltech Aarhus University. Bright targets require a large number of pixels to capture the entirety of the stellar flux, or the energy of the radiation coming from a star, the researchers wrote in a paper published August 11 in the journal Monthly Notices of the Royal Astronomical Society. CCD saturation, as well as restrictions on data storage and bandwidth, limit the number and brightness of stars that can be observed. CCDs are charge-coupled devices, which Kepler's camera uses to record incoming photons, or particles of light, as pixels in a digital image. When too much light hits the camera as it's looking at a star, the central pixels become saturated with light, which causes a very significant loss of precision in the measurement of the total brightness of the star, the Royal Astronomical Society said in a statement. This is the same process which causes a loss of dynamic range on ordinary digital cameras, which cannot see faint and bright detail in the same exposure. While the central pixels in an image of a star become too saturated to take accurate scientific measurements of its brightness, the unaffected pixels around that super bright spot still contain accurate information. This is useful for measuring changes in the brightness of these so-called variable stars. The study's authors report, the solution to observing bright stars with Kepler turned out to be rather simple. Tim White, an astrophysicist at Aarhus University in Denmark and lead author of the study, said in the statement. We're chiefly concerned about relative, rather than absolute changes in brightness. We can just measure these changes from nearby unsaturated pixels, and ignore the saturated areas altogether. After measuring the light around a star, White and his colleagues found they still needed to adjust their data for any changes in the spacecraft's motion and possible imperfections in the camera's detector. Even the slightest error could prevent the researchers from detecting a star's variability, the authors suggest, adding those errors could be corrected using simple algorithms. To account for any discrepancies in their measurements, the authors developed a new technique to weight the contribution of each pixel to find the right balance where instrumental effects are cancelled out, revealing the true stellar variability, the Royal Astronomical Society's press release said. White and his colleagues named this new technique halo photometry. Using this new technique, the researchers confirmed that 6 of the Seven Sisters are slowly pulsating Type B stars, which change in brightness over the course of one day. These observations are not news to astronomers, as those stars' classifications have been known for some time, but the study did help White and his team test out their new photometric method by using the Pleiades as a guinea pig, Aarhus University's Stellar Astrophysics Center said in a statement. This image from NASA's Kepler spacecraft shows members of the Pleiades star cluster. The brightest stars in the cluster, Alcyone, Atlas, Electra, Maya, Merope, Taygeta, and Pleione, are visible to the naked eye and were nicknamed the Seven Sisters in ancient Greek mythology. Kepler, which was designed to look for alien planets, has a hard time photographing stars this bright, and the images are distorted, with long spikes. A new technique called halo photometry allows astronomers to study these stars by looking at distorted images like this. Credit T. White and Aarhus University. The seventh star, named Maya, is a bit of an outlier, with a brightness that fluctuates over a much longer period of 10 days. Previous studies of this star's light spectrum have found that Maya's atmosphere is also chemically peculiar, containing excessive amounts of certain elements, most notably manganese. These two weird characteristics are related, the researchers discovered. What we saw was that the brightness changes seen by Kepler go hand in hand with changes in the strength of manganese absorption in Maya's atmosphere. Victoria Antosi, a co-author of the study and assistant professor at Aarhus University's Stellar Astrophysics Center, said in the statement, We conclude that the variations are caused by a large chemical spot on the surface of the star, which comes in and out of view as the star rotates with a 10-day period. The researchers said that this finding may help settle an ongoing debate in astronomy about something called Maya variables, a subclass of variable stars proposed by Russian astronomer Otto Struve more than 60 years ago. Struve coined the term to account for the strange behavior of Maya, which he thought to be a variable star. However, other astronomers have since investigated the strange star and suggested that there is no need for such a classification. Still others have said that Maya was never a variable star to begin with. 60 years ago, astronomers had thought they could see variability in Maya with periods of a few hours, and suggested this was the first of a whole new class of variable stars they called Maya variables, White said, but our new observations show that Maya is not itself a Maya variable. Whether Maya variables actually exist is still up for debate, as other stars have been labeled with the unofficial term. But at the very least, perhaps, it's time to rename that controversial class of stars. The unique brightness fluctuations of each star reveal clues about its physical properties such as its size and rotation rate. Most of the bright stars in the Pleiades are a type of variable star called a slowly pulsating B star, but Maya is different, showing evidence of a large chemical spot that crosses its surface as the star rotates over a 10-day period. Credit to White Aarhus University. While this research didn't lead to any new exoplanet discoveries, which is Kepler's primary purpose, the methods the researchers developed to work around the bright light problem will be useful in the continued search for Earth-like planets outside the solar system, the researchers said. In the paper, using halo photometry, researchers can now look for exoplanets orbiting bright stars like the Seven Sisters, NASA's next big planet hunting mission. The Transiting Exoplanet Survey satellite tests could also study brighter stars with the help of halo photometry, the authors wrote, adding that even the James Webb Space Telescope can take advantage of this new method when it starts peering into the depths of space in 2018. Email Hanneke Watering at watering@space.com or follow her at HannekScience. Follow us at space.com, Facebook and Google. Original article on space.com.